Chapter 6 Lines and Angles, Part 3. So, in Part 2, you learned some problems. We will continue in Part 3 also. That is exercise 6.1, fifth problem. Exercise 6.1, fifth problem, you see. In the given figure, POQ is a line and ray OR is the ray which is perpendicular to what? PQ. Perpendicular to PQ. OS is another ray. OS is another ray lying between OR and OP. Okay. Prove that angle ROS, this angle is equal to half of angle QOS minus POS. This you have to prove. Here, this angle you have to find out. Okay. This angle you have to find out. Okay, this is a very important problem. Very important problem. Repeated question. Very important problem and repeated questions. Listen carefully. Given, what is given here? First you write that. What are the things given here? POQ is a line. That is okay. Then OR is perpendicular to PQ. OR is perpendicular to PQ. That is given. OR perpendicular to PQ. Okay. Then OS is another ray between OP and OR. OS the ray OS is between OR and OP. OP and OR. Okay. To prove, try to prove. What you have to prove is angle ROS equal to half of angle QOS minus angle POS. Okay. So here you have to find out this angle. Okay. This angle you have to find out. Okay. So proof. See, what I am going to do is, first one, right hand side. What is right hand side? You have half of angle QOS minus angle POS. Okay, I am going to find out this right hand side, angle QOS minus angle POS. Okay, first to find out angle QOS. What is angle QOS? How will you write QOS? You see, QOS is nothing but this 90 degree plus this one. You have to split this because this fully water. QOS. Okay, you have two adjacent angles. One is 90 degree plus ROS. So you can write it 90 degree plus angle ROS. That ROS only, okay, we have to find out. So you have to bring that ROS. Clear? Next, what you have? POS. What is POS? How will you write POS? Right? This full 90 degree. That is POR. Subtract this ROS. Means you will get POS. Okay, you will get POS. POS is nothing but full 90 degree. Minus ROS. So 90 degree minus ROS. Okay. Here we used that linear pair axiom. That is what you have. This is straight line. Here what 90 degree you have means another 90 degree you have. 90 plus 90, 180. Clear? ROQ 90 means ROP also 90 degree. Okay. That's why we are writing here POS is nothing but, this is nothing but full 90 minus ROS. Okay, so here you can write the reason, linear pair axiom. Linear pair axioms. We used that. Okay. Now you subtract these two. Subtract. Therefore, angle QOS minus angle POS. Angle QOS minus POS. You subtract means first you write this 90 degree plus angle ROS minus of, okay, 90 degree minus angle ROS. So now what you have to do is you remove the bracket 90 degree plus angle ROS minus 90 degree minus of minus plus angle ROS. So this 90 get cancelled because 190 minus 90, there is 0. Now one angle ROS plus another angle ROS, two angle ROS. Two angle ROS. Therefore, for my convenience, I am going to write two angle ROS is nothing but angle QOS minus angle POS. Okay, the same thing is nothing but this one. Okay, now this 2 you divide this side. Therefore, angle ROS is equal to half of angle QOS minus angle POS. Okay, hence proved. So many times repeatedly asked this type of questions. Clear? So very important practice. Here what you have to do is right hand side what is that? That you have to find out. Then subtract. Then you rewrite here. Clear? Then divide these two means you will get. You see this problem very important. So diagram not given. You have to draw the diagram. Okay. So read the problem correctly. It is given that angle XY is at 64 degree and XY is produced to P, to point to the point what P, to the point P. Draw a figure from the given information. Then if ray YQ bisects angle ZYP, then find angle XYQ and reflex angle QYP. Okay, two angle we have to find out. First one, you have to draw the diagram. That is very important. For that, mark is also there. Okay. So XY is it. For my convenience, I am taking like this. The angle XY is it. First draw XY is it angle. This angle I am taking 64 degree. That is here X. 64 degree. This angle is somewhat 64. 64 degree is given. Okay. Now next what you have to do is ray extend. Here XY is produced to P. XY produced means you have to extend XY to P. Okay. This XY you have to to P. XY you have to extend to P. XY produced or extend to P. Clear? So next, if ray YQ, so from Y you have to draw one ray. From Y you have to draw one ray. Ray YQ bisects ZYP. Correctly what it is, divide into two equal parts. Bisect means what? Divide into two equal parts. This ray YQ ray y cube divides into two equal parts. That means this angle equal to this angle. Both are same. Both are same means you have to mark like this. This is the diagram. Now you have to find out xy cube. You have to find out xy cube. Clear? For my convenience, I am taking this is x means this is also x. Okay. So first we can find out x means, then easily we can find out xy cube. Xy cube easily we can find out, because this full angle is how much? Straight angle, that is 180. So here x plus x, 2x plus 64, 180 degree. Then minus 64, 180 minus 64, subtract means we will get 2x. Then x easily you can find out. Then you add this 64 and 1x, means you will get this xy cube. Then reflex angle QYP. QYP is what? QYP is only x. Okay. Then reflex angle means this angle, that is 360 minus, always reflex angle QYP means you have to what? Subtract from 360. Clear? Easily will get. So now what is given, you write. Angle XYZ. 64 degree it is given, right? Then xy is produced. Xy is produced to P, to the point P. Then another one thing is given, ray YQ. YQ is the ray bisects angle ZYP. ZYP. Okay. These things given. Now we have to find out to find angle XYQ and reflex angle QYP. So these two things you have to find out. So solution, to find means you have to write solution is okay. So first what it bisects, that is YQ bisects the ray YQ bisects, that you write bisects angle ZYP is given, bracket you write given. That means this angle equal to, okay, this angle equal to, that is ZYQ is equal to angle ZYQ is equal to angle PYQ. That is equal to x. For our convenience, you take xc. That is equal to xc. Clear? Now, since PYX is a straight line, clear? But PYX is a line. Okay, it is given. Therefore, you can add all the three angles, x plus 64, x plus 64, that's equal to 180. Okay, that is straight angle. Straight angle is always 180 degree. Okay. Now x plus x 2x. X plus x 2x is equal to this 64, bring this side, means 180 minus 64. So 2x equal to 180 minus 64, 10 means 6, 7, 6 means 160. Okay, 116. Now you divide by 2, that is x is equal to 116 by 2. How much? 2 table means 5 times 8, then 58 degree. That is x is equal to 58. Now easily we can find out this what angle xyq. Therefore, angle xyq is nothing but x plus 64. You see, xyq is nothing but x plus 64. That is equal to what? X is 58. 58 plus 64. 12, 122. 122. So we have to find out reflex angle QYP. So here QYP, first to find out QYP is nothing but x. Therefore, you write here angle QYP is x. That is equal to what? 58. 58. Therefore, reflex means subtract. See, reflex angle QYP means you have to subtract 58 from 360. That means 360 minus 58. That is how much? That is equal to 302 degree. 302 degree. Okay. 302 degree. Clear? So reflex means always subtract from 360. Means you will get reflex angle. So they asked the two angles. The two angles are, one is 122 degree, another one is 302 degree. Okay.
Next we will see parallel lines and a transversal. A line which intersects two or more lines at distinct point is called a transversal. A line which intersects two or more lines at distinct points is called a transversal. You see the diagram. In the above figure, line L intersects lines M and N at points P and Q respectively. You see the diagram, M is one line, N is another line. The L intersects M at P and N at Q. Clear? Therefore, L is a transversal for lines M and N. Observe that four angles are formed at each of the points P and Q. Let us name these angles as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. In the above figure, angle 1, angle 2, angle 7 and angle 8 are called exterior angles. You observe that angles in the diagram. You see angle 1, angle 2, angle 8, angle 7. That is outside of the lines, two lines. Okay. So they are called exterior angles. While angle 3, angle 4, angle 5 and angle 6 are called interior angles, that is inside the lines. Lines M and N, inside you see 4 angles there, 3, 4, 5, 6, clear, are called interior angles. Recall that in the earlier classes you have named some pairs of angles formed. When a transversal intersects two lines, these are as follows. A. Corresponding angles. In the figure you see how the corresponding angles are. First one you see angle 1, angle 5, angle 2, angle 6. Angle 1, angle 5, same side of transversal. in the same form. In the same form, you see angle 1, angle 5. Angle 2 and angle 6 also in the same form. Okay, so these are called corresponding angles. Then angle 4 and angle 8. Inside you see angle 4 and angle 8 in the same side of transversals. Clear? In the same form, the angle in is same form. Clear? Then angle 3 and angle 7 are corresponding angles. Next one, alternate interior angles. Alternate, you see the transversal line inside angle 4 there. Okay. Then alternate angle, that is 6, alternate angle 6. These two angles inside the line, so interior angles. Okay, so angle 4, angle 6 are called alternate interior angles. Same way another pair you see, angle 3, angle 5, these two are alternate. Clear? One side angle 3, another side angle 5. Clear? Center you have what? Transversal line, one side angle 3, another side angle 5. These two alternate angles. Okay, it is inside the line, so interior angles. So angle 3 and angle 5 are called alternate interior angles. Same way you have alternate exterior angle, that is angle 1 and angle 7, and angle 2 and angle 8 are called alternate exterior angles. Next one, interior angles on the same side of the transversal. Inside the line, in the same side of transversal, you have two pairs. You see angle 4, angle 5 and angle 3, angle 6 are called interior angles on the same side of the transversal are also referred to as consecutive interior angles or allied angles or co-interior angles. Further, simply we use the words alternate angles for alternate interior angles. So simply we can say alternate angles. Clear? We used to call alternate interior angles. Clear? Now let us find out the relation between the angles in these pairs when line M is parallel to N. You know that the ruled lines of your notebook are parallel to each other. So with ruler and pencil, draw two parallel lines along any two of these lines and a transversal to intersect them as shown in the given figure. So now you see the transversal of parallel lines. The two lines which never meet with each other are called parallel lines. If you have transversal on two parallel lines, then all pairs of corresponding angles are equal. See, you see angle 3 equal to angle 7, angle 4 equal to angle 8, angle 1 equal to angle 5, angle 2 equal to angle 6. Next, all pairs of alternate interior angles are equal. You see the diagram. Angle 3 equal to angle 6, alternate. Angle 3 and angle 6 are alternate because 3 is one side, 6 is another side. Clear? Center you have transversal, 3 is one side, 6 is another side. Okay, both are interior angles. That's why what it is, alternate interior angles are always equal. Same way, angle 4 equal to angle 5. Next, the two interior angles which are on the same side of the transversal will always be supplementary. That means angle 3 plus angle 5 is 180. Sum of the interior angles on the same side of transversal is supplementary, that is 180 degree. Angle 3 plus angle 5 180. Same way this side angle 4 plus angle 6 also 180 degree. So now very important thing, transversal axioms. 1. If a transversal intersects two parallel lines, then each pair of corresponding angles will be equal. You can find in the diagram, see the corresponding angles 118, 118, that is equal. Same way this side 62, 62. Clear? So they are equal. So always two lines parallel, then each pair of corresponding angles will be equal. Same way, each pair of alternate interior angles will be equal. You see the alternate interior angles 62. Okay, alternate interior angle 62, 118. Interior, inside you see, inside the line you have 62, you see alternate interior. Again 118 you see alternate interior angles. Clear? Or equal, they are equal. Next, each pair of interior angles on the same side of the transversal will be supplementary. Supplementary means 180 degree. So each pair of interior angles on the same side of transversal, you see, you add in the same side of transversal two angles add 62, 118 add means how much? 180. Same way this side also 62, 118, 62 add means again 180. So each pair of interior angles on the same side of the transversal will be supplementary. Second, if a transversal intersects two lines in such a way that corresponding angles are equal, then these two lines will be parallel to each other. So if you have two lines, one transversal there means all the corresponding angles are equal, means then the two lines we can say parallel to each other. Same way, alternate interior angles are equal, then two lines will be parallel. Interior angles on the same side of the transversal are supplementary, then we can see two lines will be equal. That is just one reverse of the axiom 1. Reverse of the axiom. Clear? Lines parallel to the same line. If two lines are parallel to the same line, then they will be parallel to each other. Let us check. See in the figure, L, M, N are parallel lines. T is transversal. You see, line M parallel to line L and line N parallel to line L. You draw a transversal T for the lines L, M and N. So it is given that line M parallel to line L and line N parallel to line L. Therefore, we can find angle 1 equal to angle 2, angle 1 equal to angle 3, that is corresponding angles axiom. Therefore, angle 2 equal to angle 3. Why? You see, angle 1 equal to angle 2 and angle 1 equal to angle 3, both the left hand sides are equal means and right hand sides also are equal. That is angle 2 equal to angle 3. But angle 2 and angle 3 are corresponding angles and they are equal. Therefore, you can say that line M parallel to line N, line M parallel to line N. Okay, you see the angles 2 and 3 are equal, means corresponding angles. When corresponding angles are equal, then the lines are parallel. So line M parallel to line N. So lines which are parallel to the same line or parallel to each other. This is very important axiom. Lines which are parallel to the same line or parallel to each other.
So same type of problem I will give it as homework. You do the homework problem